So this is about data mesh. I hope that you know what a data mesh is, because this is not an introductory course. This is not a presentation about Databricks, about the data products, and how this whole organizational paradigm works. It's about how you create an actual data mesh, how you create an architecture, the choices that you have to do when you have this kind of requirement, that you have to actually deliver a data mesh compliant architecture. So this is a speedrun. This is will take less than it will take your coffee to get cold, and will contain most of the questions that I wished someone could give me the answers to way back when we started designing and approaching this problem. So first thing that you will know about the data products in a data mesh is that they should be independent. And you know that you have independence between the different data products, and these data products are by their own nature delegated to different teams, and this is how the organizational paradigm works and what is supposed to be their how it's supposed to work and how it's supposed to be created. So the problem with that is that once you give full autonomy to any team to choose any technology, any method of scheduling things, and who make their own decisions about everything, then you end up with a fragmented ecosystem. And this is an inherent danger in when you create a data mesh, because at some point it's all well and good of the various teams knowing their data and delivering the best they can based on their data, but at some point you have to deliver cross-organizational data. You have to create derivative data products that are based on, let's say, the initial data products, the ones that are created by the relevant teams. There is some integration work there, there is some aggregations, and there are those kinds of things. So first thing that we wanted to address is how we can do this and how we can alert other data products that something has happened on a data product. And you can go with choreography, you can go with orchestration, and despite their names and the eternal debate between them, most of what comes in from the mind of the developer on how they approach the different flavors of orchestration and choreography. So we opted for a hybrid approach. We have all our not real-time data products go through Airflow and be orchestrated there. We are doing a heavy use of the Airflow's datasets. So in essence, we are passing around messages between the different data products based on their state and on the status, where each data product then is on its own responsible of starting its recalculations or the fetching of new data or anything that is needed. So this can be achieved easily using an Airflow implementation, and we've done this so we can have a complete overview of the state of our data products. So not all teams, each team doesn't control its own orchestrator. We have a single orchestrator doing everything there, where each team is responsible for creating the relevant things. Another question is, how do we do the heavy lifting? What about big quantities of data, big quantities, big velocities, and all of that? We opted for Databricks because it's familiar Spark on steroids. A lot of developers know that and know their way around it, if it's Spark or if it's Databricks. There is also this granularity in access control that Unity Catalog gives us, and also data lineage, because it's a big part of the Unity Catalog, and the functionality it provides is essential for having data products, because you should be able to give out relevant rights, you should know your lineage, and not all organizations are as mature to have a proper data governance tool. So this is can play the role also for stand-in for a data governance tool for when it's needed, at least for the developers and the people that need to know who has access and what's the lineage of relevant data. About data quality, because it's important for a data product to provide a data contract with metrics about its freshness of the data, about the quality of its data. And there we've gone for using the Great Expectation Suite. Why we go for that? Mainly two reasons. Because it works like a charm in Databricks, because it's Python and it's loved by developers, and also because it provides some very robust reporting that is actually human readable. So you can go out to business users and inform them of what the actual errors are. It's not that this weird SQL or Python code has failed its execution or has returned 0 rows or anything like that, but it is something that it is there for the business people to understand that this is failing because of that and that reason in human readable language. So it's very easy to communicate and requires much less time from the developer side to explain the various errors. What is also interesting is that, okay, we've opted to consolidate all of the data products in a data lake, and this is an Azure solution for using the data lake over Databricks. And we understood at some point that some cases, some data products have needs that cannot be addressed properly by Databricks, no matter what it is said, meaning that translytical solutions that everybody is evangelizing lately. So we took a step back, rolled back to previous strategy, and we have dedicated resources as an Azure SQL or an Elastic Web Service that we use for specific niche applications of the data product, serving data over the internet one tuple at a time. No Databricks for that. It would cost an arm and a leg, and it doesn't make any sense. So we've built a two-tier storage solution where everything until the gold layer is in the Azure Data Lake infrastructure, and then there is a subject of the gold layer where it is needed in Azure SQL or in Elastic or whatever it is needed at each point. What we wish that we knew when we started, it seemed initially that these were good ideas. Okay, we're data engineers at heart, so we started focusing on the data. No, the data product is much bigger than that. You shouldn't focus only on the data. Of course, data are the meat in the meat and potatoes dish, but this is far greater in how you should approach it. Also, we decided to do something about our infrastructure and starting creating different infrastructure based on the domains that created additional complexity because, in essence, the infrastructure should come from the needs of the data products, not from under which domain they fall on. So initially, we thought that similar data products will have similar needs. This was not the case. Also, we left the data catalog for a later stage. Not as good as a decision. Okay, the organization could be reluctant to adopt a solution, but it's something that we should push and strive for a data solution to be. There are excellent free open source solutions that we can use, and this initial investment pays dividends. So it's really important to have a data catalog when you're building a data mesh. Otherwise, you end up with a data mesh with a double S. Things that we did from the start. We knew that not only Databricks will serve all needs. We would need additional tools. We tried to create a coherent ecosystem so people can move from one thing to another, that we have not a fragmented data estate, and we have strived for some specific guidelines. But we also allowed for some flexibility, and when these needs aroused, like complex searching or transactional-like usage patterns, we switched the underlying technologies, and we knew that we should switch them right from the start. We also did a really good job in defining our domains, our data stewards, the governance behind that, which is really, really important when you're building a data mesh. Again, because this autonomy that is central to the idea of data mesh can create issues when not properly governed. Also, this thing that we got about orchestration, that we had a single Airflow instance and created that and used a single Airflow to have a complete overview of what happens when. It really works like a charm when we try to address and monitor our systems. When we have this harmonized data mesh, because we opted for that solution. There are other solutions, but this is the better one for organizations that don't have very stringent needs on how they govern their data, meaning that we allow inter-data product communication without a centralized infrastructure or a centralized system. So this allows for more flexibility and amplifies the independence of the data products. What we ended up creating was more or less this. We have a data hub, which is a solution for the data governance, which is an open source one, and it's something that really supports all the tools that we are using, because that's also another plus, because not all data governance tools support all tools. So for this was better for us. We have the orchestration done with Airflow. We are using GX and Databricks to perform all of the transformation and all of the data validation what we are using. And we are also having some external things like the Azure SQL database or the Elastic Web Service to disseminate data to downstream consumers that have specific needs. Last, what we created is this data product blueprint. This is a generic version of what we are calling a data product. It's not the only way you can build a data product. It's just a way you can use to build a data product in Databricks and around these Azure-centered technologies. But this is really an important thing because we have blueprint, we have this template that it's shareable between the teams. So all teams start from a common base. It's not a straitjacket. It's not something that they have to adapt to no matter their needs, but it is something that will get them up to speed and will enable them to use some concrete technologies and push them to use the expertise that we have as teams. So it is really working in enabling us to deliver faster and better data products using a almost standardized approach. And with that, I want to thank you for being here. And of course, I'm open to any questions. Thank you. Yes, please. Data quality, we build our data quality solution around the Great Expectations open source suite, which we create our rules, our validation tools on top of it. So we can communicate with the relevant stakeholders and the data stewards, which are non so technical, more business-oriented people, to better exchange with them both the rules that they need the data to be validated against and the results of this validation on a daily or on a weekly basis, depending on the rate that we update the data product. So this is how we started to use this. We have also been using this as a part of our testing scenarios to identify issues during the development phase, but it's in place also in production, so we get the alerts and we can decide on whether we need to update the data product or if we are below the thresholds of the data product, that the data contract that we have published, meaning that we are missing like more than 3% of the expected records for a day. This will drive a decision on the part of the system whether to continue to support this data product as being valid or the threshold has been reached and now this data product is not valid. And then you have the decision on whether you keep the previous version of the data product to be made available, which was validated but stale, or you inform your downstream consumers that their data product is no longer valid and shouldn't be used for their intended purpose.
Any other question? Okay, thank you, Nick, for your presentation. We can proceed to the lunchtime.
Thank you.